Okay. Oh, jeez. Alright, I see the microphone thing moving now. I'm sorry about all that. I don't know what was going on. When the blue lights are on, it should be working, but I mean, I do have my little command console here, and it wasn't registering that there was any audio input on that screen either. But um, well, actually, it's second for now. What I was saying about that, well, is there were a few ways that we could go about doing that. This set up was really because one of my things is I don't like getting too complicated with loop structure and just setting the limits on the loops. Let's see. Now I see some lagging stuff, but let me check and make sure. Yeah, I think we're good now. So yeah, apologies about that. Um, yeah, I'm not the best at shortest mode. This is how small I got it down to. Changing index down to just I and stuff like that. But yeah, so I don't know. Pretty happy with that one. All right, let's see. And let's go and do another. Are we showing up here? Nice. All right. I also just recently figured out, I'm like 100 clashes deep, and I figured out these are chat rooms for the individual clashes, so that was cool. All right. Find what score student got with the question and what he answered. If the student was John, question amount was 3, and the question sheet was that, you should output John got 2 out of 3 because 1 plus 1 does equal to 2. Oh. So we're going to have to evaluate questions. Let's see. This one might be a little trickier. So already I know that I want to make a couple variables. So correct equals 0. Um, Total. Or that's just question amount, so we don't really need that. Um, yeah, right. Thanks for letting me know because I've done that before. I've done an entire stream where I'm just talking to myself, and yeah. Although that was because I had actually clicked mute, not because like the equipment was being weird. So, all right. Okay, so I think the biggest part of this one is just evaluating the questions. So we're going to want to do it nested in this loop because this is going to go for everything question amount. All right, so the question op list equals. I'm going to try doing it this way. So um, op list equals question dot split. So then we'll have all the pieces. Then we can check. Oh, this is going to be a nice. Also, we're going to need to build a return string. Sorry, trying to cover all my bases as we go. So a return string to build, to return, well, or to print, I guess. And then just so we have that. And we're going to have 3 if cases, or no, 4. Sorry. Oh, geez, there's the other one that finished. Let's see. Check it that way. elif. default. We'll do the multiply. So now we need to check it and then add that to return string, or no, um, increment correct. So if 0 plus op list at 2 equals op list. So it's going to be 1, 2, 3, 4, 5. So index 4, correct, plus equals 1. Alright, now we just got to do that for the other conditions. And that is a little sloppy just making it an else, but I mean, as long as the input is correct, like, oh, use the eval function? Let me look that up real quick, because that might actually be a lot slicker to do. Eval Python. Yeah, because I've seen that before. Let's see. I mean, this should work as well. It should be like, only we would just change. We'll go ahead and keep going this way, and I might change it, but I like to just make sure I get it fit, and then, oh, should we force these to, I mean, eval already is probably a lot easier than all this. But I also like it this way because then you can kind of see what's going on. Let's see, we got a, might also need a double divide on that. Go ahead and let's see if this works first. We're not, we're going to win this one. Yeah, 3 people done, perfect, and then another opt to 20%. Which, especially if you do a calculator type app or a program like this, you can shy away from it. But maybe not if I did the eval. Oh, and then return string. I'd have to build it, but let's just do print correct to see kind of what our counts are doing. 0. So, look at this eval. So eval question. Let's try that. See what that does. Oh jeez. So that doesn't work. Let's see. So eval evaluates whatever's in the parameter. So the example I'm seeing here, print 55 will do it. Since these questions are all, yeah, I would say those are valid Python statements. So let's see. Yeah, the conversion. Oh, Although this is still not incrementing correctly. So I'm wondering, let's set it equal to the fifth thing. And the reason I'm, thinking about it this way is because, if they have double digits, but it's still items split. So, yeah, no, that's fine. Um, that, oh, yeah, I guess take out the bug. Alright. Let's, what is it not? I mean, I don't think that's the issue, because this has been pretty forgiving with, yeah. Why? Why is it? Let's see. Let's see. Why is it zero? What did that evaluate to? Oh, wait. Because you're doing the equals. I'm just trying to type what was in the eval parameter to a Python interpreter. You do 1 plus 1. Oh, so maybe slice it to. Ah, see, that's getting all tricky and stuff. Because if you just did execute 1 plus 1, then you should do 2. Let's see, I'm looking up at an example now. Yeah, I'm seeing like the eval function being passed the first parts, but not the equals. So we're already supplying the equals. So in order to get around that, I would almost have to. Um, I mean, if we're doing it with a list, we could pop the last two values, which would be the answer and the. But this way should work. Like this one, if we were to, get rid of all this, go back to just trying to do. I mean, unless my indices are incorrect, but no, that should be right. Like the zero, the first one, and then we're splitting on spaces, so this should be 0, 1, 2, 3, 4. 3, sure. So And then correct is not. Let's go ahead and try that again. So correct is getting 0. Um, okay, just what is going on here? All right. Um, yeah, and then it reiterates. There's that, but yeah, it's not evaluating to any of these. So, hmm. So I was thinking about doing like first and second and assigning those to those, but this should be, yeah, none of them are triggering. Let's do. Oh, whoops, timed out. All right, I guess we didn't do so hot on that one. Okay. I'll look into this a little more. Let me make a note of that. But, oh, I see. Yeah, replacing. Okay, no, that makes sense. Yeah, and that's what I was kind of figuring out at the end of that was that's not a real Python statement. Yeah, you're right. It would have to be equals equals. So okay, but that's cool to know. I mean, let's go ahead and try another one, and then. All right, shortest mode. Parse. Oh, sorry. I should. Um. Oh, good point. You're right. I didn't cast the last one either. I cast the first two. That was probably why it wasn't incrementing. Nice. Okay. Well. All right. And sorry, I need to share the links. I apologize. I'll try to do better on that before the clashes. I'm still kind of getting used to that. But all right. So parse the regular hexagon and tell how much regular unit triangle do you find if the length of one side of the regular hexagon is n units. As it is well known, every regular hexagon, I haven't done geometry in years, that has a positive integer value for the length of one side can be split into a positive integer value of regular triangles, where the regular triangle has sides with, dang, see, I was already done with 12. Alright, anyways, has sides with 1 unit of length. For example, if the hexagon has sides with 1 unit of length, it will be split into 6 triangles. That makes sense. Like the hexagon and all the triangles meet in the middle. If the hexagon has sides with 2 units of length, it will be split into 24 triangles? Alright, that got a little trickier. Number of regular 1 unit triangles inside the regular hexagon. Is that it? Oh, I was gonna say, is that how simple it is? But okay, so how would that be? If one gets 6 and two gets 24. see, now we're overshooting. I'm trying to figure out how to get 24 from 2. So, I mean, it was kind of easy enough to visualize. Like if I were to draw, I don't have any scratch paper here. Huh. No, this will work. But if I were to look at a hexagon, oops. If I draw a line to every point, oh, yeah, it makes 6 triangles. I mean, the 6 flat sides are the bases, and then the points be in the middle. I just, I guess I just don't understand how it not only doubles, it quadruples. And I'm trying to figure out how to make that scalable. Like, 1, it's easy enough with doing these multiplication things and squaring things because it just gets you 1. But whatever you do with 2, I mean, so it's not only double, it's quadruple. So, I mean, I know it's just some simple thing like this, like whatever n is, the unit. 1 gets 6, how does 2 get 24? So, it'd be n times 6. I mean, 36 would even make sense, because then you could raise it to the n. But 24, I mean, and that's why I was thinking it would be like times n squared, because then times 4 would be, that would make sense. It would go back to that. But this gets, let's see, how far off? I mean, 1, yeah, okay, we got that. Yeah, we're over triple this one is, so that's not. Yeah. Oops. Wait, is that it? 2n times 6? Alright. Or wait, no. No, it's n times. Okay. Alright. So I guess that's. It's weird. That hurts my brain. But whatever it is, like I said, I haven't done geometry in so long, and whenever I get these geometry questions, yeah, that's about as short as I'm gonna get it. 9 characters, that's pretty good for me. So that's plus that one. There aren't too many ways you can make little zingers out of that. So, all right, go ahead and do another. Let's see. Got to go run some errands soon, but I'm gonna try to do a few of these streams today. So, because I'm at, let's see. Oh man, I think I'm at like 125 clashes, and I'm trying for that 500. So, oh, never mind. I'm at 149, so it's a little closer, but still a long ways to go. So we just did what? Two? I think we've done three clashes. So, all right. Oh, and sorry, I forgot the link. Anyways, the Japanese abacus, also called a soroban, is a device consisting of several vertical columns interrupted by a horizontal bar. Each column has one bead above the bar and four below. The beads may be moved freely up and down along the column. Each column represents a digit of an integer. Each lower bead counts one and pushed up toward the bar. If the upper bead has been pushed down to the bar, it counts 5. Write a program to display as many columns of a soroban as necessary to represent the given integer. Use I'm gonna take a look at what this is real quick. Let's see. Okay, so there's a row of beads, bar, and 4 rows of more beads. Hmm. Okay, so there's 5 rows because there's an empty row. I get it now. So space where there is no bead. That's what these lines are. Okay, so for this one, all of the beads in the top part are pushed up. So 31,402. That is so strange. Let's see. Oh, I guess I'm just so confused by this. I mean, I'm not even happy with our normal abacus. Like, how we're doing some. Let's go and get all this stuff out. All right. So based on the input, we have to adjust this soroban accordingly. Yep, and output it. So each of these columns is a base 10. I guess that's kind of making sense. I'm trying to figure out. So it counts 1 if it's been pushed up. So for here, we have 1, 2, 3, or 5. Ah, see that? Oh, I get it now. Since these are all pushed up, if we look at that example number, we're trying to get a 3 for the first digit, so that's 3 pushed up. A 1 for the second one, so that's only 1 pushed up. I get it now. Okay. But how to translate that into an output? I mean, I'm thinking of a way to do it with a very gnarly if-else tree. Very gnarly. Like, I mean, I could hard code 10 situations. So this is one would be, yeah, this is one. the second column. Also, let's look at all the digits. Yeah, because let's see, how big is that? 1, 2, 3, 4, 5. Wait, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, mm, for every digit, we're going to need to add another column. If the digit is greater than 5, or 5 or greater, then these will be pulled down. This would be up. So see, like right here, if this was the first one, though that looks like they're out of order. But anyways, if it's 5 through 9, this would be a bar. So it'd be like this. And then this would be an asterisk. That's 5 through 9. And then you can do the other 4, like 6, 7, 8. 6, 7, 8, 9. Yeah. Oh. Alright. Sorry. Um. Okay, so I really like this puzzle, but trying to figure out how to print. I had something similar to this yesterday too, or it might have been last night, where you had to print out a digital representation of, so like the old digital clocks, like you got the bars, yeah. So for numbers, and that was the same concept. So basically, creating like a 2D array where each of the rows is constructed, and then doing something like this, printing out each row, or I guess it could just be one giant string put together with, new lines. But the problem is every time there's another digit. So what, you know, first off, I'm thinking a for loop for, like for char in string cast of n. You would construct this 2D array of, so like already you'd be like, if int char is greater than 5. Well, see, no, that's I mean, I'm almost thinking that's just dividing, like dividing whether to have it this way or this way. So like with the bead up or the bead down for the top row, meaning 5 to 9, or if it's up, then that means that column represents 0 to 4. So, but the only way I can really even think about doing it, ugh, like if char equals 0, do something, and then elif int char. I mean, obviously that 0 is going to be skipped quite a lot because the leading one's not going to be, or it's always going to be skipped for the first one, but, then equals 1, and so on. I'm just doing it because I don't know if we're actually going to get this in 5 minutes. Figure out how to construct that 2D array. I mean, I might save this for later and see if I can't do it. Because I love the idea. Like I saved the code for the digit one. I mean, I didn't finish the digit one from last night or whenever it was. But, oh, wait, what am I doing? So it's 8, 9. So those are all the possible conditions for a base 10 number. So then we would also have a return string or 2D list. Whoa, why is it red? Huh. 2D. Well, I guess it would just be a list, and then you would add a list of a list for each of these lines. But you would always, see, that's just, okay, no, wait a minute. So, in order to build this, you would actually just be adjusting the first list, meaning the column. No, because each of these would be, huh. Because I've done an encryption algorithm to do that, where you do it in columns rather than rows. And that was, I think maybe something like that could work here. Yeah, exactly. Exactly. That's what I'm saying. It's like you'd have to do it column versus row, manipulating it. Zip. Let's see. Zip to print them in the right direction. Let's do zip. Hmm. Wow, pretty nifty. Well, I mean, if we were doing it this way, I mean, it's not very optimized. Nested for could have 10 nested for loops potentially. So based on which digit it is, it would go into there, and then that would modify the return string to add another column. I wonder. No, it would have to be hmm. Because I've got zip pulled up now. Yeah, it looks exactly like what I would need to do this. Oh yeah, probably gonna time out on this one too. I don't feel too bad. Say only one person. Oh jeez. Mm. I think I would use it. That's a good way to go. Yeah, 12 seconds. So Yeah, zip. Let's see. Wow, that is it's definitely short. No. Oh, that's you? Yeah, that makes sense. Okay, yeah, I'm looking at yours right now. Yeah, that is brilliant. Yeah, I'm not very good at that, like making them all short like that. Especially smashing in like a for loop in there, a map, like had all sorts of stuff going on in there. Oh, good job, nicely done. I like it. And you were the only one that actually finished. Everyone else, look, nobody even finished the album, So you know, my, but yeah, no one else is. Alright, I'll do one more. I don't. No. Do one more, then I gotta go run some errands, and then. Well, no, I love it. Like, I mean, like, it's a very slick way of doing it. Like, it's very complex. I mean, that is like the epitome of the short mode. So good job. Yeah, you smashed that one. Um, yeah, I've just never been very good at um compacting things into one line, like for loops, if conditionals. I like to see it spread out, facing. Otherwise, my brain around. But let's see, let me get rid of a few of these. Yeah, I make some games or not like mine, where I'm algorithming writing this stuff. But I think I figured it out. I'm trying to convince one of my colleagues to jump on this cooking game stuff. He's a lot better at cooking than I am, but it did a lot longer. But I think it'd just be I love cooking game is fun. I'll say that. I did the link again. I keep getting distracted. All right, I'll try to do better on that. So let's see. So let's convert the input duration to the specified human readable format. Oh, this one's kind of annoying. All right, so I know that they can get pretty intense, but basically we gotta separate out. Yeah, it's days, hours, minutes, seconds. Okay, so days D. Oh, what is it gonna be? We know we have days, hours, minutes, seconds. There's moduloing and dividing. Actually, one of my favorite, or one of the only four katas on board I've done is exactly this. It's this format. It's a lot harder because if it was like a day, like a lot more for this format because whatever it is, you just put that number and then a D like that. And if there is none, oh wait a minute, I said that, but then we can yeah exclude them. See, so if it's zero, this is never mind. So this isn't as forgiving as I thought it would be. I need to check. So if it's greater than zero, print it. Yeah. So first we need to calculate what is a day out of seconds. So how many seconds are in a day? Go ahead and see that. Um, so we have 60 seconds in a minute times 60 for hour times 24. 8,400 seconds. Right. D divided by 86. Then after that, D equals uh, equal thing. Uh, D modulo E 400. So hours D divided by 3600. Then again D equals D modulo 3600. And um, x equals D divided by D equals modulo 60. Then divided by 6. Or wait, no. Seconds doesn't matter. We're in seconds. We don't need to do that. D modulo 60. I think. We got not 100% on. First, we need to make sure we're actually getting the correct values. We don't worry about that. Okay. Wait, what? 3 hours and 20 minutes? Oh, milliseconds. Ah, see. Okay. So, that's annoying. Alright, well, we're going to do D divided equals 1000. Try that again. Boom. Okay, so, um, that fraction bit. So, D equals D double dot, keep it integer. I believe it's correct. Here you go. So, as you can see, we now have hours, 20 minutes, 0 seconds. So now we are getting the correct thing. So now we got to do on this shortest mode. Uh, we'll see. I just want to get one correct. I mean, I don't care. So, all right. So return string. All right. Now, if days greater than 0, return string plus equals string days. Plus D. Now we just gotta oops, plus base. Replicate that a few. There we go. Change these to lifts. Yeah, and see, one code word got me was it's like 1 day. You know, one was different than 0 or more than 1. So here we're only checking if it's greater than, know, any. So hours, we have this, we have this, I have things like that. First example. Oh, huh. These do need to stay as ifs. Okay, now do hours. Need to remember my hours, seconds, hour, minute, seconds, turn, r strip. There we go. What did I get? Oh, right. We don't print that anymore. It's looking good. Alright. I mean, it's looking massive as all get out, don't get me wrong, but oh, give me the test. Sorry, our strip is not working. Um, there we go. Bada bing. No. Oh. And here, if length, jeez, turn string equals, whoops, outside. I mean, I didn't mean to get this one sucked into that conditional, but I think that should work. Yeah. So now we've got, you know, yeah. Cool. All right, so that's functional. We got almost 4 minutes to make it smaller. Okay. Oh, we got it. I said I wasn't super confident about that one because I'm not good at that. So return string already could be, you know, R. Let's go with that. Make everything R. And we can also shrink. Oh, stop. It's so annoying. The one thing I don't like about it, you figure out turn it off. That right there, it pops up. It's like, oh, hey, by the way, it's useful when you want it, but when you don't want it, it's annoying, especially if you're starting to get some build up. Let's see. Do D. Or no, we'll do A for days. this will be M. And I don't know how far I even want to go. I mean, we got time. We got 2 more minutes. S for seconds. Take out all the spaces. Let's just make sure I didn't break it. Cool. Still passing. Alright. A bit of a nasty trick to set it in milliseconds. That's kind of annoying. But, I mean, it's at the same time. It forces code to do one extra conversion. Let's see. Oh. Funny, when I was getting my degree, I actually practiced simulation of an old school computer where you had this actually was a thing. You had to worry about how much space your code would run. So it was struggling. You know what? I just want to make sure, does it still work? We got 40 seconds. Okay. I mean, we're getting down to the nitty gritty here. Let's see, right there. It's like, with my luck, I'll break it right as we're supposed to submit it. Yeah, that's good. 12 seconds. Let's make sure it works. Everything's good. Okay. It's still a lot longer than it probably needs to be, but I'm happy with it. Alright. Well, I think I'm going to go run some errands, and then I'm going to come back and I'm going to try to do some more of this. But yeah, I'll go ahead and share my code. Now, yeah. Let's see. That's see this stuff like at all. That's really cool. Like their calculations of the actual value that took a lot of because they're doing it as you go using the same variable. Alright, cool. Well, this was a fun class. Good to end on. Yeah, this is with my luck, I would have just like to see or something. Would have. I know that you can different. Yeah. All right. Well, input and definitely think of me my mic recording. That was about it. So we had a pretty decent clash for the first one. That was all quiet. So, anyways, have fun. I'm gonna opt out for now. Like I said, I'm gonna go do some errands. I should be done there. I do some officer too. So, see my little green mushroom man float. So, all right, well, I'll see you around. Thanks for stopping.